नमस्कार विद्यार्थी मित्रो, आधीच्या व्हिडिओमध्ये आपण क्वेश्चन नंबर 2 हा कंप्लीट केलेला होता. Now we'll see the question number 3. Carry any two activities of the following with the help of the information given in the figure. Fill in the block boxes to find AB and BC. Now in this case, AB is equals to BC. This is the given thing. And next, that is the angle BAC is equals to angle BCA, and that is equals to 45 degrees. This is the right angle isosceles triangle. Now therefore AB is equals to BC is equals to, that is a root 2 into AC, and that is a root 2 into 8, that is the value of the AC is root 8. Now this root 8 can be written as 4 into 2, that is a 2 root 2, and therefore overall that is a, you will get that is AB is equals to BC, then we will substitute the values. Now we'll see the answer of this question. That is a AB is equals to BC, angle BAC is equals to BCA, that is equals to 45. Therefore AB is equals to BC, that is a 1 upon root 2 into AC, that is equals to 1 upon root 2 into root 8. Is 1 upon root 2 असं म्हणायला पाहिजे होतं. That is 1 upon root 2 into root 8, that is equals to 1 upon root 2, that is a 4 into 2, that is equals to 2 root 2. This root 2 get cancelled, and then you will get that. Therefore the AB is equals to BC is equals to 2. Now next question. That is here 1 upon root 2 into AC. This must be there 1 upon root 2 into 8, 1 upon root 2 into 2 root 2. That is a root 2 get cancelled, and then you will get the 2. Now next. In the adjoining figure, the chord EF is a parallel to chord GH. Prove that the chord EG is a congruent to chord FG. Fill in the boxes and write the complete proof. Now in this case, we'll see the direct answer of this. Now here what's happening? That is the angle EFG is equals to angle FGH. These are the alternate angles. Again there, angle EFG is equals to 1 upon 2 measure of arc CEG, that is the inscribed angle there. Angle FGH is equals to 1 upon 2 measure of the arc, that is a FH, which is again the inscribed angle there. Therefore from these two, that is from 1 to 3, we have measure of the arc EG is equals to measure of arc FH from the 1 to 3. And that's why we come to the conclusion that is a chord EG is a congruent to chord FH, that is a corresponding chords of the congruent arcs. Now we'll see the next question. Now in this question, that the side of the square is 7 centimeter. D is as a center, DA as a radius, AXC is a drawn. Find the area of the shaded region with the help of the following flow charts. Again, this is very simple. Now if you see this, find out the area of the square and then subtract the area of this sector. That is a sector D dash AXC, and then we can find out the area of the square, find out the area of the sector, and their subtraction will get the answer of this question. Now we'll see the area of the square, that is a side square, which is the 7 square, that is equals to 49 centimeter. Now again, the sector D dash AXC, area of sector is theta upon 360 into pi r square. That is a 90 upon 360 into 22 upon 7 into 7 square. And after the calculation, you will get 154 upon 4, and that is the 38.5 centimeters. units are also very important. Area of the shaded portion is equals to 49 minus 38.5 and that is equals to 10.5 centimeter square. Therefore, the area of the shaded portion that is equals to 10.5 centimeter square. Now we see the next question, which is the question number 3. Solve any two of the following questions. Now, in the figure MNP, measure of the angle MNP that is equals to 90. Segment NQ is perpendicular to segment MP. NQ is equals to MQ is equals to 9 and QP is equals to 4. Then find the value of NQ. Now, this is the geometric mean that we see in the chapter similarity. That's a perpendicular to on the hypotenuse. Thus, that is the NQ square is equals to the MQ into QP. This is, now we'll see the answer of this question. Now NQ square is equals to MQ into QP. That is a theorem of the geometric mean. That is 9 into 4. That is equals to 36. Therefore, NQ is equals to 6. Now, next question is, the question is from the trigonometry. Prove that sec theta plus tan theta is equals to cos theta upon 1 minus sin theta. It's a very simple question from the trigonometry. Now we'll see the answer of this. Now sec theta plus tan theta, that is we consider the LHS. LHS is equals to sec theta plus tan theta. But what about the sec theta? Reciprocal of sec theta is cos theta, that is we write here 1 upon cos theta, and tan theta means what? Sin theta upon cos theta. Now both of them have the same denominator, therefore we can add it. That is 1 plus sin theta upon the cos theta. Now next thing is 1 plus sin theta multiplied n and d numerator and the denominator by 1 minus sin theta, and after a plus b, a minus b means what? A square minus b square upon cos theta into 1 minus sin theta. Keep it as it is. Now what is a 1 minus sin square theta? Is basic identity, that is a sin square theta plus cos square theta is equals to 1. Therefore 1 minus sin square theta is cos square theta. Now this cos square can cancel and you are getting the cos theta upon 1 minus sin theta, and that is our RHS, and hence LHS is equals to the RHS, that is a sec theta plus tan theta, that is equals to cos theta upon 1 minus sin theta. Now we see the next example. The radii of the top and the base of the frustum of a cone are 5 cm and the 2 cm respectively. Its height is 9 cm. Find its the volume, and here the pi is equals to 3.14. We see answer of this question. Now here R1 is equals to 5 cm, R2 is equals to 2 cm, and H is equals to 9 cm. The area of the frustum, that is the now here R1 is equals to 5 cm, R2 is equals to 2 cm, and H is equals to 9 cm. That is the volume of the frustum is equals to 1 by 3 pi H in bracket R1 square plus R2 square plus R1 into R2. Now substitute the values. That is 1 by 3. The value of the pi is 3.14 into 9, 5 square plus 2 square plus 5 into 2. And after the calculations you are getting that is a 3.14. And division of this, that is a 9 upon 3, that is a 3 in bracket 25 plus 4 plus 10, and that is 39. That is 3.14 into 3 into 39, and after the calculations you are getting the 367.38 centimeter cube. Again I am saying that is the 367.38 centimeter cube. That is therefore the area of the frustum, that is equals to 367.38 centimeter cube. Now we'll see the next example. That is the theorem. Prove that if a line parallel to a side of a triangle intersect the remaining sides in the two distinct points, then the line divides the side in the same proportion. Now this is the very important theorem, that is a basic proportionality theorem. सर्वांनाच आवडत असणारा थेरम आहे. सर्व विद्यार्थ्यांनी याचं प्रिपरेशन केलेलंच असतं. निश्चितच तुम्हाला हा थेरम सोपा जाईल. Now in this triangle, that is a triangle ABC, the line L is a parallel to the base BC, and then this line is L intersect AB at the point B, and line L intersect at the point AC at the point Q. Now what's happening here? बऱ्याच वेळा विद्यार्थी मित्र तुम्ही थेरम वगैरे सर्व नीट व्यवस्थित करतात आणि परीक्षेत मात्र थेरमचा सगळा प्रूफ गिव्हन टू प्रूफ सगळं लिहिलं जातं. तर काय तर फिगरच नसते. तो विदाउट फिगर द थेरम इज नॉट पॉसिबल. जेव्हा तुम्हाला स्टेटमेंट दिली जाईल परीक्षेला त्याच वेळेस तुमची फिगर ही सगळ्यात जास्त इम्पॉर्टंट आहे. नाउ द गिव्हन in triangle ABC, line L is parallel to side BC. Line L intersect the side AB and side AC in P and Q respectively. To prove that AP upon PP is equals to AQ upon QC. Construction. Draw the segment PC and the segment QB. Now in this case, what's happening? That the area of the triangle APQ upon the area of the triangle ABQ is equals to AP upon PP, and this is one. That is the area are proportional to their bases. Both of these two triangles have the same height and their areas depends on their bases. For the next, that is the triangle APQ upon the triangle P. Area of the triangle PQC is equals to AQ upon QC, and this is it. That is the areas are proportional to their bases. Now if you see this, that is a triangle PPQ and the triangle PQC have the same base PQ, and PQ is parallel to BC. That is, their height is also same, and therefore area of the triangle PPQ is equals to the area of the triangle PQC, and this is the third one. Therefore these two ratios are equal, and hence that is AP upon PP is equals to AQ upon QC, and in this way we have to prove this. Now next question is from the construction. That is draw a circle with the center O and the radius 3.5 centimeter. Take any point P at a distance of 5.7 centimeter from the center. Draw a tangent to the circle from the point P. That is, we draw the here circle with the center O and the radius is 3.5. And from the center, we take the point P at a distance of the 5.7 and draw the perpendicular to the OP and take the perpendicular segment, whatever that point, using that point you take as a center and draw the circle. Then this is very simple questions from the construction. I will show this video to how to draw this tangent at the last of this video. Next, line PQ is a parallel to line RS, where the points P, Q, R and the S have the coordinates 2, 4, 3, 6, 3, 1, 5, K respectively. Now find the value of the K. Line PQ is parallel to X. As these two lines are parallel, they have the same slopes. Therefore, find out the slope of the PQ and the slope of the RS and equate them, and you will get the value of the K. Now we'll see here the answer. Slope of the line y2 minus y1 upon x2 minus x1. In this way we will find out the slope of the line PQ, which is a 2, and same the slope of the RS, which is the k minus 1 upon 2, and in this way equate these two, that is the 2 is equals to k minus 1 upon 2 cross multiplication, and you will get the value of the k, that is equals to 5. In this way, my dear student, we have completed this question. Up to this question, that is a question number 4, and it's a sub question is a 3. Now we'll see in the next video. Till then, goodbye.